Okay, so, yep, lesson 21, reviewing a lot of algebra 2 here. Just remember, if you go to move something and it's added or subtracted within the parentheses, in the absolute value, in the square root, whatever it is, if it's within with the x, that means the graph is going to go left or right, opposite the sign. If the number is added or subtracted at the end, it's going to go up or down. That's basically what that top is saying. So, graph the function y equals absolute value of x, then change the equation to shift the graph 3 units to the left and down 2 units. So ironically enough, you guys should have just been here last period. I just taught this. Because we're on lesson 2.7, which is absolute value graphs. Okay, so what do you remember about just graphing y equals absolute value of x? Okay. Now, when I graph, I'm going to back up for a moment. When we graph y equals absolute value of x, you may have said it and I missed it. Because I believe I heard vertex at 0, yes. What's the graph look like? It's a V, and what are those pieces of the V doing? How are they going up? Like a up 1 over 1? Like a slope of 1, right? Okay. So, traditional absolute value graph, vertex 0, 0, and the sides of the V go up 1 over 1, right? They basically, officially I should use the word slope, but it is like a slope of 1, isn't it? Because there's no number multiplied out front there. Okay? Then, what Ross was talking about, if we're going to shift it 3 to the left, remember that 3 is in the absolute value, plus 3 means we're going to go left 3 because it's opposite the sign. And then down 2 is going to be a minus 2 at the end. Yes? Let's see. Can I sketch a graph of that real quick? So if I go left 3, down 2, puts my vertex here at negative 3, negative 2. And then from there, I can go up 1 over 1. And your graph should end up cutting through the x-axis at negative 1 and negative 5, I believe. Technically, if it cuts through the x-axis at negative 1, it cuts through my y-axis at positive 1. Okay. We definitely did that in Algebra 2. We did some of that in Pre-Cal, right? Because officially, absolute value is one of our 12 graphs we learned. But hey, my Pre-Cal kids start into that tomorrow. It's all tying together. Okay. Graph the function y equals 1/2 x squared, then change the equation to shift the curve 3 units right and up 2 units. Well, let's start with y equals 1/2 x squared. What are your thoughts there? Okay. It is a shrink or a compression. What? Okay, it's a parabola. What do you know about a traditional parabola? Okay? So, in a typical, and I don't know if you guys want to think about this or not, but if you want to revert back to y equals x squared, right? When we first did that, well, you would have done it in Algebra 1 some, but we did it in Algebra 2, right? The basic xy chart I always taught was 0, 0, 1, 1, and 2, 4 is your positive side, right? And then you also have, of course, the negative side. Now, when you do 1/2 x squared, options. We could make a new xy chart if you want. Or what does a shrink of 1/2 affect? Well, if I just look at, I guess what I'm trying to ask is if I just look at my xy chart here, am I taking half of my x values or half of my y values? Half of your y values, right? So if you know what this, the 0, 0, 1, 1, 2, 4, you can just cut each of those in half because it's a vertical shrink is what it is, or vertical compression. Now, if all else fails and you're like, I don't like doing that, then, you can use an xy chart, can't you? If I put in 0 squared and do half of it, it's 0. 1 squared is 1, half of 1 is 1/2. 2 squared is 2. 2 squared is 4. Half of 2 is 2. If we go one more to get the shape, 3 squared is 9. Half of 9 is 4.5. Okay? Point is, either make an xy chart or understand that shrink of 1/2 is going to affect the y values. It's a vertical shrink. So, 0, 0, 1, 1/2, 2, 2, and then 3, 4.5 if you're doing that. It says then change the equation to shift the curve how? 3 somewhere. 3 right, 2 down. So what's that equation look like? I'll give you the y equals part.
Y equals x minus 3 squared plus 2.
X, because we're going 3 right, so x minus 3 quantity squared, up 2 is a plus 2 at the end, and you still have the 1/2 out front, yes? Except you can't see my plus 2 now. Always something. Okay, so that is the new function, and this is where, I don't know, let's see. We graph this. Basically just need first quadrant for the most part. Okay. So instead of centering at 0, 0, it's going to center at 3, 2. If you wanted an XY chart here, now that we know 3 is my centering point, you would plug in numbers like 4 and 5 and 1 and 2. Numbers on either side, right? Or you can use the points that, okay, earlier it was 0, 0. That's my 3, 2 now. From that point, over 1, up a half. If it was 1, 1/2, we can go over 1, up a half. And I can do that in both directions. From my vertex, I can go over 2, up 2. And if you really want to, you can go over 3, up 4.5. Sorry, not a very good parabola, but you get the idea. No ways to work with them, right? Okay, example 3. Unless you're going to object to anything I'm doing. Graph the function y equals 1/2 x. Oh no, do we know how to graph something like that? I don't know. We sometimes get so far in that we forget the basics. How do you graph y equals 1/2 x? What about 1 over 2? Okay. Okay. So we have a slope there of 1 over 2, rise over run. And in this case, because we have nothing else, my y-intercept starts us at 0. So rise 1, run 2. I can go back and go rise 1, run 2. Okay. Now look at what they ask us to do. Change the equation to shift the graph 2 left, down 1. So how am I going to write my equation here? Okay. So we still have the 1/2 out front. To go 2 left, that means we have to add 2 to x, and I'm going to do that in a set of parentheses. And then to go down 1, we have a -1 at the end. Do me a favor and clean that up. Because in all honesty, would you graph an equation in that form? Probably not. I don't know, I guess maybe, but if we clean this up, what's it become? Distribute the 1/2, 1/2 x plus 1. You still have a -1. Clean it up again. What is it? Y equals 1/2 x. Do I need to graph that? No, it's the same thing, isn't it? Because my shift was 2 left and down 1, that goes along with my slope, doesn't it? So it's the same line. Okay. That took some brain power. However, that was like all stuff we could have talked about in algebras. Okay, well, let's get a little fancier here. Talk the pre-calc trig stuff. Given y equals absolute value of 4 sine x, change the function to shift the graph down 2 and pi over 2 units to the right.
Y equals -2 plus the absolute value of 4 sine x minus pi over 2.
Maybe. I'm not sure I 100% caught up. Like I was kind of watching, listening, and so if we write the equation here, and then I'll come back and graph it here in a moment. We were given y equals absolute value 4 sine x, right? And then if we are going to go what? Down 2. We can do this in 2 different ways. I think Ross You put your -2 out front, didn't you? And that's how we've seen it before also, because when you go down 2, that's our new, what's the vocabulary we've used? Center line, right? So you can call it your new center line. You can also put the -2 out back, which is what, as I'm looking at my notes, what I did, just because it kind of fits in the form with what we're doing with everything else. What I would say at this point is you need to realize that down 2 could be shown out front or out back. Okay? Pi over 2 to the right means right there with my x, I'm going to have an right pi over 2 would be x minus pi over 2. So if we absolute value of 4 sine parentheses x minus pi over 2 in parentheses into absolute value, and I think the only thing different is I was going to say -2 at the end. However, I'm perfectly fine with putting -2 plus out front instead.
Well, I would not ask you, but the way to calculate it's always first.
They put it first, yeah. And that's why any math person assessing math stuff is going to be fine with it either way. So needless to say, the AP math, on an AP test, something like that's not going to matter. It's equivalent. So, okay. So we talked about that -2 is how far down we go. Also, if you compare it to what we've done previously, it is our center line. The pi over 2 was our right pi over 2. What is this 4 called? Our amplitude. These words ring some bells, right? And then, what's that absolute value bar going to do? It's going to make it all positive, right? It's going to flip the entire graph up, if you will. I don't know how you want to say that, but see, here's the difference. My blower has been turning on and off today, or higher and lower, and it hasn't in the past, because you guys are all saying my room is warmer today than it has been. So, and I agree, I haven't felt as cold either, but I'm sure it will be cold after lunch. Always. All of you 5th period pre-cal kids understand that. Okay, let's graph. Now, as we graph this, I'm going to do this a little bit differently, because I'm going to take us back to the beginning. First of all, I'm going to, my whole right side, I'm going to call that, what is one cycle of sine? 2 pi. I've got pi in the middle, and the middle of the middles are pi over 2 and 3 pi over 2, correct? I'm going to go ahead and do the left also. So equivalent markings, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi, just trying to keep them equivalent markings. And we're going to start with graphing the original. So I'm going to, when I label up and down, I'm going to just label up 4 and down 4. From 0 is what I'm saying there. So I'm going to go as high as 4. And as low as negative 4. And I can zoom in on the graph so you guys can see what I'm doing here. Ooh, okay. Someone is seriously stealing my pencils. I'm like down a mechanical pencil every day. I had like a bazillion that seemed like the beginning of the school year, and disappearing. Okay, so if I feel like I've lost another one today, unless one of you are the thieves, that takes it down to 2nd or 3rd hour. Huh? Our left and right is going to matter because we're only moving it pi over 2 over. So it is going to matter. So, okay. So what I was going to have us start with is just, okay, what does, if we forget absolute value for a moment, what does sine x look like with an amplitude of 4? And I'm just going to lightly trace this in pencil. So sine x will go where? It goes up to, in this case, 4, right? It peaks, or it cuts through at pi. It's going to have a minimum under 3 pi over 2, and it crosses through at 2 pi. And we can reverse this and go the other way, right? We don't do this very often, but we can, I hope, maybe, in that you would have a minimum under negative pi over 2, cuts through negative pi, max out at 3 pi over 2, crosses through at negative 2 pi, right? Now, with that in mind, okay, what does the absolute value of 4 sine x look like? Yeah, so this parts up above are still good, right? But parts underneath, and I'm just doing dotted lines here, right, are up. So now everything stays above the x-axis, right? So this is the graph we're going to try, and what are we supposed to do with it? Down 2, and pi over 2 to the right. If I go pi over 2 to the right, what am I doing here? Yeah. Each of these x-intercepts are scooching over 1, right? So if I'm going to go pi over 2 right and what? Down 2? Does that make sense if I say I'm going to have a point down there now? The one at negative pi, if I go pi over 2 right, down 2. At 0, 0, pi over 2 right, down 2. At pi over 2 right, down 2. And then 2 pi, it's going to be off the graph right now. The other thing you can move, I moved the minimum points, so like my x-intercepts. And I can also move my maximums, yes? So the top here of this graph was above negative 3 pi over 2, so it's going to go right to negative pi and down 2. So that's going to be my top of the mountain now. This one was above negative pi over 2, so I'm going to move it over to the axis, down 2. So basically these tops are going to be right 1, down 2. They're going to be in between where the current tops are. If I take this one right, it's going to be over 2 pi, down 2. And so the idea is we can now make our hills. And I'm just kind of, whoops, trying to connect my dots. I kind of goofed that one up. And if you want to put one back over here, just to make it, whoops, dang it. There would also be one above negative 2 pi and 2 up. Okay. So that purple graph is the new graph there. And again, just trying to have you guys see all the movements, see all the changes. Okay, I'm ready for example 5 whenever you guys are. Do not use your calculator on 5. Just saying. Do not pull them out and start graphing on your calculator. We're going to use exactly what's there. So start studying number 5 to decide How do I know which graph is which? If she's not going to allow me to grab my calculator out. So in other words, what this is saying is if you typed in f of x, g of x, and h of x on your calculator, typed in those equations, and you went to just a standard Zoom screen, your graph would look like, or your calculator would look like this. Now, what I want to know, which of those graphs is f, g, and h, without you using your calculator as an aid. So there's definitely a way to do it that works here. We're getting some thoughts. Okay, so what do we mean the plus 6?
So the last value is what so that one is plus 6. This one has a minus of 6, so that's the value. And the other one doesn't have a constant value. The first one doesn't have a constant value, so the answer is 0. The next one's constant value is -3.
Okay, he threw in the word intercepts, right? What are we basically talking about? We are talking about the y-intercepts, right? As we talk about the y-intercepts happen when x equals 0, right? So it is a piece of cake. The one you guys mentioned first is 6. If I take 0, I think my purple pins are dying here. I have to find different ones. Yep. If I take g of 0, if I put 0 in for g, it's going to be 6. Notice there's a y-intercept here of 6. So this graph right here is g of x. Okay. If you put in 0 to f, you get 0 out. So I don't even know where to draw it here. This middle graph in here is f of x. And lastly, if you put in 0 for h, you get -3. And so this bottom graph is h of x. Now the key thing you just did, whether you knew it or not, was your y-intercepts. Okay, questions on that one then? Obviously your calculator would confirm. Yeah, I think that this purple pin should not be done, but I think that one is. Okay, moving on. Graph y equals 1 over x by hand. Thoughts on this one? Okay, make an XY chart. So Ross is saying he doesn't remember what this one looks like. Okay. So if we think XY chart, what happens when I put in x equals 1? Y is going to be 1, right? What happens if I put in x equals -1? Y is going to be -1, right? So you have a point down here. What happens if I put x equals 0 in? Okay, we can't do it, right? So that means x equals 0, there is a vertical asymptote. Okay. Now, what happens when we put in, say, 2? If x equals 2, it's going to be 1/2, right? So when you go over 2, you're only up 1/2. What happens when you put in 3? It's 3, 1/3, yes? Do you remember this graph at all? Looks something like this. It had a name. It was one of our 12. What? This was the reciprocal. I feel like there's another name we talked about also. Oh, I know. It's an example of a hyperbola. That's what we talked about. Which, when we really were graphing hyperbolas, we were graphing the ones that were either horizontal or vertical, not the diagonals. So, okay. So, this number right here on top, this 1 represents if there's like a stretch or a shrink type thing. But other than that, it's just those 2 curves facing out. Okay? Now, example 7. How am I going to change my graph now? Okay, we have translations. This is up to, and this -3 with the x is going to go right 3. Right 3 up to, I'm really just going to, well, just going to really have the right side of the graph. Can't see what I'm drawing though. In the previous graph, I didn't really draw in the asymptotes, did I? Because the asymptotes were my axes. On this graph, that's my recommendation, is that you draw in the asymptotes. If we're going to go right 3 up 2, well now that's kind of like my new origin. So what I would do is when I go right 3 up 2, if that's kind of my new origin, I'm going to make my asymptotes at that point. So basically, my vertical asymptote moved right 3. My horizontal asymptote moved up 2. And those are my new pieces. Based on the fact I have 1 on top here, it's still just numbers that multiply to be 1. And so yeah, you do have a point that's 1, 1 in reference to that. That's not the greatest thing, but okay. This is last example, isn't it? Yes. Making sure I'm not forgetting anything here. Last period I taught, I was all finishing up. I was like, I'm writing the homework down. I was like, wait a minute. It just dawned on me. There's a 3rd page on this. Crud. Totally goofed up my timing last period. Okay, example A. Thoughts? A reflection. Officially, because the negative is out front of the equation, I would say a reflection across the x-axis. However, in this scenario, it's the same, because I could take that negative that's out front of the fraction and I could put it directly on the x, and I'm not changing the value of this equation. So, because a negative on the x is a reflection across the y, a negative out front is a reflection across the x. However, it's all the same on this one. So basically, my graph, instead of being in quadrants 1 and 3, it's going to be in quadrants 2 and 4. And that's because there was a reflection. Okay? These probably are our trickiest one here. Okay, how did you say it? Sorry, I was trying to process. Okay. That would work. The other option is you could go, okay, so we can think of this one in two different ways. First of all, because it bugs me, if I flip it, this is 1 over negative x plus 3, correct? Which, yes, you can think of that as a reflection across the, left 3, reflection across the y. Is that what you said, I think? The other option you can do, and what you tend to see them do, is you tend to see them, they'll factor out a negative on bottom. And if you factor out negative, then it's a negative of x minus 3. Because, so the way Ethan said it, we'd have to do move left and then reflect. Which means even though you just moved and put your asymptote on the left, when you reflect it, your asymptote then goes to the right. What to me makes, I don't know, what I think I'd rather do, wait a minute. Am I saying this right? My brain just had a moment of, am I saying this right? Because x minus 3 is right 3. I know it, okay. Just had to write it out. And that negative is a reflect, yes? What I would rather do first, got it, is I would rather do my reflection first and then move it right 3. As opposed to moving it left or right first. In that case, it'd have to be left. And then when you reflect it, you'd reflect the whole asymptote over the x-axis. Over the y-axis. I don't know if I'm making sense there or not, but I always have to pause and think on these, I'll be honest. Just as easy for me to get confused as you guys. So, I would say reflect first, which if I reflect this, basically means instead of being in quadrants 1 and 3, we're going to be in quadrants 2 and 4. And then if I move this right 3, we've got our asymptote over there. It's one of those things where order does matter to an extent. Okay. And C, when you're ready, what does y equals 1 over x squared do? Makes your y values positive. So, what's that mean? Instead of quadrants 1 and 3, quadrants 1 and 2. It almost, in a sense, has a similar effect as absolute value, doesn't it? Because you put in an x value, negative or positive, and it comes out positive no matter what. Okay, so absolute value and squaring something similar, not identical, but similar. Okay, I decided that was the end of the notes.